and this is my glider presentation. First, I will talk about the requirements. The initial requirements of this project were to create a working design before beginning the building process. We were also required to do research prior to creating the glider to make sure we did it to the best of our abilities. The design requirements were to make it smaller than 16 by 16 inches, make it primarily of balsa wood, and it must be properly balanced. The flight day requirements were that the glider must fly at least 20 feet, must be hand thrown, and must stay intact during the entire flight. For the initial requirements, I created an initial sketch and I changed it as the project progressed. I also looked into others' designs and did lots of research to make sure my glider was the best that I could make it. For the design requirements, I researched different designs and I constructed my glider mainly out of balsa wood, and I made sure to balance it correctly. For flight day requirements, I made sure to test fly it beforehand and alter the weaknesses. I practiced my throwing technique to make sure it was the best that it could be, and I used extra glue and extra stabilizers where it was needed to make sure my glider stayed intact. In materials, I considered using wood and hot glue globs to weight down the front of my plane, but I ended up using Play-Doh instead because it made balancing easier. For the wing shape, I considered using a rectangular straight wing, but I ended up using tapered straight wings for easier construction. For wing placement, I originally placed the wings more towards the nose, but I ended up moving the wings further back to make balancing easier. For the dihedral, I considered adding a dihedral, but I decided against it because it made construction too complicated. And for tail configuration, I considered using a V-tail, but once again, it would make my construction a little too difficult for me, so I ended up using a conventional tail configuration. And for adhesives, I originally used super glue, but I ran out and did not use enough, so I switched to hot glue after a fatal glider crash that left my glider in pieces. For materials, the pros is that balsa wood is lightweight and good for gliding, and Play-Doh is easy to manipulate. The cons is that using balsa wood and hot glue provided to be an insufficient way to weight the front of the glider. For wing shape, the pros is that rectangular straight wings are easy to make, but the cons are that the wings would not be able to glide as far as the tapered straight wings would have. For wing placement, the wings' weight being closer to the front would contribute to the balancing. However, the further back they are, the more lift the glider will get, so placing it closer to the front would inhibit its flight. For the dihedral, when it's the correct angle, the flight quality is improved. However, finding the correct angle and appropriately installing it proved to be very difficult, for me at least. And then for tail configuration, two tail wings being at the correct angle would act as both the vertical and horizontal stabilizers, but it would be much harder to build and to get the same angle on both sides. And for adhesives, super glue is light and would hold the pieces together better, but I would need much more super glue to hold the pieces together properly. Now I will talk about alternatives that have a higher probability of success. First, the dihedral. I believe the dihedral alternative has a higher probability of success because it would allow for much more lift and airtime. And for tail configuration, I believe the tail configuration alternative would have a higher probability of success because it requires less pieces and would make the flight more stable. Now I will talk about the sizing of my glider. Originally, my glider was much bigger than the final result, but I had to make the wings smaller because I forgot to read the directions. But I still ended up having longer wings than most for the main wings and the tail wings, and the body is also quite long. Glider, it was much too big. It was 20 inches by 15 inches, and it was too big. Also, most of the features in my initial sketch did get scrapped. I did have outer wings that angled upwards and my tail wings angled upwards, but I ended up scrapping that because I could not get it right when I was building it. But yeah, most of the dimensions stayed very similar except for the wings getting smaller. Talk about my design iterations. Like I mentioned, I changed the size to 16 by 15 inches. I removed the dihedrals from the design for ease of construction, and I added a slight curve to the tail wings to have more lift When I first started balancing the glider, I placed the wings on 2 equal Chick-fil-A cups and figured out which side I needed to add weight to. I needed to add it to the front, so I kept adding Play-Doh until it was equaled out and it would hover between the 2 cups, and then I put tape on it to secure the Play-Doh. The location of the center of gravity and the final design of my glider is located about 3.8 inches from the front of the vehicle. This point is in front of the quarter cord of my wing. Now I will talk about the calculations I did to find the lift coefficient and drag coefficient. For the lift coefficient, I used this equation here, and I found that the answer was 0.548. For drag coefficient, I used the equation under drag coefficient, and I found my answer to be 0.0125. Here's the video of my best flight. It went a total of 40 feet.
Yeah, exactly. Mine says like positive.
My final thoughts: overall, this project has been very fun and educational to complete. It brought more insight to the world of aerospace engineering, and I'm very excited to dive deeper. If I could go back, I would tell myself not to make such ambitious designs that are definitely above my ability. I set very high goals for myself, and I had no experience, so I was set up for failure initially. However, I am very proud of how my glider ended up, and I put my blood, sweat, and tears into it, quite literally, and the satisfaction of seeing my glider go above and beyond the requirements was immense and great. Here are my works cited.